Awesome, guys. All right, so we're back with the CCNA journey. We left off, like I said, we were on chapter 8. We were reviewing um chapter 8, which is implementing Ethernet virtual LANs or implementing VLANs, right? We covered this lab as far as we were talking about VLAN tagging concepts. Oh, it looks like my key is joining up. We were covering VLAN concepts. Um, we talked about trunking, and of course, we actually, and I'm proud to say this, we actually ran into some issues as far as trying to verify trunking. Come to find out, of course, it was the software. Because again, we're emulating, right, the software, not on a switch, but on a server. So, of course, sometimes we're going to have issues. So let's just double check, make sure everything's working. Give me 1 second. So trunk, right? Show interface trunk. There we go. Awesome. All right. So our trunk is working. We're not getting that native VLAN mismatch anymore. There we go. Awesome. All right. So we're good to go. Right. So let's have a discussion. Right. I want to talk about. Let me get my pencil. I want to talk about this. All right. This trunk. Right, between switch 1 and switch 2, right? What you guys are going to learn within the chapter 8, right? Um, oh, we got people just rolling in. All right. There goes Swan. All right. So what we're going to learn is that Cisco, right, supported two different trunking protocols, right? ISL, inner switch link, right, and the IEEE standard 802.1q, right? So ISL, right, inner switch link was created years before 802.1q, right? And again, you guys learn about what a trunk does. Trunk is carrying multiple VLANs across the link, right? Now, ISL and 802.1q, if we keep it simple, right, they both tag each frame
Gotta go all the way to BJ's for that, Mom.
that's traversing a link, right? They tag it with a VLAN ID, right? But here's where ISL and 802.1q differ, right? 802.1q, they insert a 4-byte VLAN header, right? Whenever it's traversing that source switch, okay, going to that destination switch, right? Okay, it's gonna have that 4-byte header. You're going to see information about, of course, the VLAN ID, class of service, the priority, the type, the flag. You're going to see all of that. You're actually also going to see um, some other things there, right? ISL is not going to have that. Okay. Um, we also have a few things that can, of course, enhance the operation of trunking, right? So that we're not configuring every trunk and seeing what trunk is allowed on a link. We also have VLAN trunking protocol, right? That we can go ahead and configure, right? Between switches, right? Um, VLAN VTP, and of course, you guys can confirm for me, VTP is not, a paramount topic when we're talking about implementing VLANs for this exam. Okay. Um, and of course, there is also going to be, and we're going to do a packet capture on this one. There is something that the switches do, right? That you guys need to know for the exam, right? We know whether they use 802.1q or ISL, they are going to tag each frame that traffic is belonging to a specific VLAN. But what happens, okay, what happens to frames that are not a part of a specific VLAN, but actually a part of the default VLAN, right? With a switch that comes out of the box, which is VLAN 1, right? That is what we call our native VLAN, right? You can go ahead and configure, right? For your inner switch link, you can configure what your native VLAN is, right? If you're looking at the screen, of course, we have a section for it here, right? I have native VLAN 1, right? I have VLAN 1 set as a native. But how does that look, right? For hosts that are associated, right, with that VLAN, right? Trying to talk from hosts from one VLAN to another, right? First, let's take a look and see how it looks like if we're communicating with hosts that are part of a specific VLAN. Okay, so first things first, let's take a look at, because it's been a while since we had our lab. Been a while, of course, Thursday. Let's see what ports belong to which VLAN, right? Let's do a show VLAN brief. All right, so where the story left off is that, right, Mykivia and of course Yasin, they configured VLAN 10 on both switch 1 and switch 2, right? And we added PC5 and PC4 to VLAN 10, right? Let's start processing, right? And enforce communication between PC4 and PC5 and see if they can communicate. Okay, let's do a ping, right? We know our source, which is 10.10.10.5. Our destination, right, should be 10.10.10.4, just for this lab. Okay. Okay. All right. And we see that working. Let's do this again, but now, right, which all of you guys are future engineers, right? Engineers in the making. We're going to do a packet capture so we can just see how that packet looks like. Okay. We're going to do a packet capture, wait for it to pop up. And we are going, let's bring it to another screen. Oh, let's erase that annotation. Excellent. Then, there we go. And hopefully we can, let's blow that up. Whoops. Can we, let's try that again. That didn't look good. There we go. You know what? We'll keep it right here. There we go. All right. So it's capturing, and let's do this. Okay. All right. We got traffic traversing. So we see that traversing link, right? Because we're capturing on switch one, right? Switch 1 gigabit 0/0, right? Let's stop it because we got what we need, right? We don't want to overload our PC. Let's take a look what this looks like, right? So we have our frame, right? We have layer one, right? We have layer two, right? And we have some information right here. Let's take a look at that, right? We have, and this is our 4 byte header, by the way, right? So we have best effort, right? We have our priority. We have our um, we have our flag, right? We have our type, right? It's IPv4. Also, what is this? We have our VLAN ID right here, right? Which is telling us it is in VLAN 10. Okay. This is what it looks like, guys. Okay. All right. Does this make sense? Whenever you guys want to troubleshoot inter switch links, you always want to get in the habit of creating a packet capture or mirroring to a port, right? To be actually correct in the field, mirroring a port to a PC that's going to capture all the packets that are traversing a link. Okay, so to confirm, hey, um, this is being tagged, this traffic is being tagged with a specific VLAN leaving the switch or being received on a switch, right? This is what you can look for, right? And of course, if I'm troubleshooting, I'm going to go ahead and first go to the source switch, right? Get to the source as close as possible and say, hey, let me see if this traffic that's leaving the switch, if it's being tagged with a specific VLAN. Then what I'm going to do, and of course I did it the reverse. I actually started at the destination, right? We actually saw traffic leaving, right, being received by the source, okay, reaching the destination switch, okay? So you guys got to look at what 802.1q a tag looks like, right? You saw what that tag looks like. It's right under that layer two section. So we're good to go, right? So let's talk about another topic, right? Let's talk about forwarding data between VLANs, right? As you guys know, we can go ahead and create a, a network with multiple VLANs, right? They are by definition, broadcast domains. Those broadcast domains by default cannot communicate, right? We can actually test that. Okay, we're on switch one. Let's put PC5, right? Let's put PC5 on the sales VLAN, right? 0/1, that's the interface, right? Okay. To be, you know what? To be correct, let's go ahead and default the interface. Okay. You always want to, if you want to change something, I don't advise just changing the configuration on the interface. Just go ahead and default it, right? If it's a lot of configurations, by the way, um, I would go ahead and copy those configurations, okay, to a notepad. If it has voice, if it has QoS, if it has, let's say if you guys have an environment that's doing that, it's going to have a lot of configuration. So copy first verify the configuration on the interface, then default it, right? But defaulting wipes any macros that we may not see, right? The software does mess up, similar to our video games. You want to make sure you wipe it fresh, then add configuration, right? So our goal here is I want to go ahead and add it to the sales VLAN, right? First, let's go ahead and confirm that it is back in the default VLAN, right? So let's do a show VLAN brief, and I have to put do in front of it since I'm in global configuration mode. Excellent. All right, so this is back in the default VLAN. We want it in the sales VLAN. Let's go ahead and do that. So let's do interface gig 0/1. Let's do switch port, which it should already be there, but we're going to go ahead and play it safe. We're going to make sure the mode for this interface is access, right? We're going to statically set that. And then we're going to do switch port access, VLAN, and we're going to say 20. Okay. All right. We're going to save that configuration. Typically, you don't have to save it every time, right? But we're going to go ahead and test it. First, we're going to verify, show VLAN brief. Excellent, right? Gigabit 0/1, which PC5 is connected to, is hanging off of VLAN 20, right? That's what it's configured to. So let's see if PC5 can communicate with PC4. Okay, it was able to before. Let's see what happens. Okay, all right. So PC4, right, which is represented by 10.10.10.4, is unreachable. Okay, why is it unreachable? Right. Well, switches, right? They're going to go ahead and forward data based off of layer two logic. I need you guys to remember that, right? If there is no layer three instance, it is going to forward data based off of layer two logic. Okay. So if we're speaking about the OSI model, it's not going to look at that layer three, right? Packet header. It's only going to look at layer two. Okay. So for routing data between VLANs, we need a layer three instance, right? To move traffic from one broadcast domain to another. Okay. So how can we make this work, right? We can we can add a router in place, right? So they can go ahead and communicate um, between VLANs. We can do that, of course, right? And I can show you that, right? But has technology advanced, right? Now switches can act, right, in multiple layers. It can not just act in layer two, it also can act in layer three, right? How can we do that, right? Let's go ahead and configure that router role, that router multi-layer role on switch one, right? And let's see what happens. So let's erase this and let's configure what we call the switch virtual interface, right? So let's create a layer three instance for VLAN 10. So we're going to do interface. Let me not do shorthand. We're going to do VLAN and we're going to do 10. Okay. And we're going to say, right? And we're going to say IP address 10.10.10. We'll say 1. So 255.255.255.0. There we go. Right. But again, our goal here, right? The goal that you guys need to learn is routing between VLANs, right? We can't just have an instance for one VLAN and no instance for the other. Okay. So Let's do the same thing, right? Let's do the same thing for VLAN 20, right? Let's do, whoops, I think I went a little bit, I went out of global configuration mode. Let's do interface VLAN 20, and let's assign this IP address as well. Okay, 10.10.10. All right, 10.10.10.2. All right. Um, to be correct, we can assign it, another IP address, but we're just gonna keep it in the, what, it's not even gonna let me do it. So let's do this. Boom, right? We'll have to reassign IP address on PC5. There we go. No shut. Excellent. All right. Excellent. Okay. So we got to go to PC5 and assign it another IP address, right? For our test to work. So let's do that. Let's do IP 10.10.20.5, right? 5.5.5.5.0, 10.10.20.1. Okay. Okay. So we have both instances, right, of both broadcast domains. Okay. Um, each host has a gateway, right? First, let's go ahead and do it, right? Let's test and let's verify per instance, right? Our first layer 3 instance, right? From PC5, that's going to be the source. Let's see if we can ping our layer 3 instance via our gateway, right? So let's do a ping. Let's do a 10.10.20.1. Okay, we're getting responses. Okay, right? Let's check now if we can ping another VLAN's layer 3 instance, right? Or switch virtual interface. Let's do 10.1. Okay. Destination host unreachable, right? We're getting that error, right? Let's see what's going on. See if we're missing something. Let's go to switch one. Put that there. Maybe we're missing that. Let's do a show IP route. And let's clear up this terminal for a second. There we go. Show IP route. Okay, so we got both networks here. We have both networks. Hold on. Brief. There we go. Okay, that's our issue. So, guys, you saw how I troubleshot. This is actually administratively shut down. That's why it's not responding to pings. Let's go ahead and fix that. In the newer software, right, in the Cisco 9Ks, you don't have to go ahead and issue a shutdown, but issue a no shutdown whenever you create the VLAN. Um, since I'm on old software, you have to go ahead and do a no shutdown. So that was my mistake. So let's go ahead and fix that. 10 shut, and we should get a terminal message. There we go. All right. So with that being said, let's see if pings VLAN 5 works now. Or VLAN 10 works now. Okay. All right. So now we get responses. Now we can see routing packets between different VLANs, right? For the final test, right? Let's go ahead and see if we're actually able to reach hosts on different subnet. Okay. Okay. So now there's communication between a host on one VLAN, VLAN 10, to host on another VLAN, VLAN 20. Okay. So that is the importance as to why you need to understand what it means to route packets between VLANs, right? And why would you need a router interface to go ahead and move that data? A layer two switch is only working based off of layer two logic. Okay. All right, let's move on. Right. And I'm going through my checklist here. You guys learned about how to create a VLAN. You guys learned about how to configure um, VLAN trunking, right? So um, you guys went ahead and confirmed that. Let's take a look. What else? take a look. All right. Okay. That is okay. Okay, we're good to go. Let me make sure. Okay, excellent. Um, One thing we do have to talk about. Let's move that and let's pull that up. Okay. While we have two switches here, we do have to talk about uh VLAN trunking configuration. Okay. Um, we can go ahead and always use 802.1q, right? ISL, but we also can tell the switch to go ahead and negotiate, right? Negotiate a type of trunking, right? Um, we can always go ahead and manually say, hey, statically say, hey, this link is going to be an access, right? It's going to be access port or it's going to be a trunk port. But we can go ahead, and I'm sure you guys are familiar with it. We can change the interface's operational mode, right, to implement dynamic trunking protocol. Okay, so how does that work, right? Let's go ahead and do it. All right, let's go ahead, and we are going to go ahead and wipe that configuration off of our trunk interface, and let's participate in interface. Let's participate. Let's try to implement dynamic chunking, right? Let's do the same thing on the other side. There we go. Default interface gig 0/0. There we go. All right. So there are different modes that we can go ahead and configure for dynamically configuring a trunk, right? Or implementing DTP, right? Here's what you need to know for the exam, right? We have, and hopefully you guys can see this, right? We have dynamic desirable, right? And we have dynamic auto. Dynamic desirable initiates negotiation messages and responds to negotiation messages to dynamically choose whether to start using trunking, right? I'm going to say this again, and let's break this down. If the command that we use to configure a trunk dynamically, we use the command dynamic desirable, it initiates negotiation messages and responds to negotiation messages to dynamically choose whether to start using trunking. On the contrary, dynamic auto, right? It passively waits to receive trunk negotiation messages, at which point the switch will respond and negotiate whether to use trunking. Okay. All right. Let's test this out. All right. Let's go ahead and get this configured. So I want to go ahead and configure this in our command. Let me leave this right here. Dynamic desirable, right? So let's go ahead and say, and go here, and I say, hey, my link is interface gig 0/0, right? And let's go ahead and configure, right? We got to make sure we put, right, so we don't forget encapsulation, right? We got to make sure we do put that since it's an old switch, right? We're going to do negotiation, right? We're going to set it to negotiation because that's what we want to do. We want to dynamically set this. We're going to do switch port, right? Mode, okay? We have dynamic, right? Because we want it to negotiate. Now, our two options, auto or desirable, right? I'm going to set this side to auto, right? Because I want to make a point here, right? Next, we're going to pull up switch two. We're going to do the same thing, okay? Right? We need to do the same thing that we did. Okay. And we're going to do auto. All right. So per definition, dynamic auto passively waits to receive trunk negotiation messages, at which point the switch will respond and negotiate whether to use trunking. Let's check the wire, right? Because if you guys are going to be network engineers, you guys need to understand what it looks like on the wire versus just relying on configuration. Okay, let's check this interface. Okay, let's see if we see any messages. There you go. We'll see spanning tree messages, but this should be an example, right? We are only listening, right? We only listening and we're waiting, right? If we configure two sides, right? If we configure two sides, and there we go. Now we see messages. But if we configure two sides as dynamic auto, the trunk is never going to come up, right? It's never going to come up. So if we take a look at this, right? We take a look at this frame, right? And we see, okay, trunk status, right? You got it set to auto, right? Negotiated. There's nothing negotiated, right? Nothing's happening. It's just straight up listening, right? And so now, if we go ahead and go to this switch, let's do the show interface. Let's clear out this terminal. Let's do a show interface trunk command. We don't have nothing because the trunk isn't configured. Dynamically, it did not come up because they're both passively waiting for one to be to request to become a trunk, right? How can we fix this? Right? Per that screenshot, right? We're gonna have to set at least one side, right, to desirable because what is it going to do? It's going to initiate the negotiation of messages, right? And also respond to negotiation messages. Okay. All right. So let's go ahead and set switch one to do that. All right. Let's do default, right? There we go. Okay. So, and same thing, right? For the exam, and of course, because the exam will be using new software, you don't have to put this switch port trunk encapsulation command. Okay. I am using older software. Port mode, damn it. There we go. And we are going to set it to desirable. Okay. All right. So we see a few things happening, right? Right. We see an influx of not just spanning tree messages. We saw for a brief moment an influx of DTP messages, right? With that being said, right, without looking at these frames, right, let's see if our trunk came up. Our trunk came up, didn't it? Right? So for the exam, you guys are going to have to know how to dynamically configure a trunk to dynamically um, configure itself. Okay. Again, if we pull up this screenshot, dynamic auto, and you will need to know this for the exam. It is a key topic. Dynamic auto, it's passively waiting for messages. Dynamic desirable is initiating negotiation messages and responding to negotiation messages, right? So if I set both switches to to dynamic desirable, they're both going to be listening and responding to messages. If I set both switches to dynamic auto, they're passively going to be waiting, right, for negotiation, and they're never going to come up. Okay. We also, of course, can set it, and this is where it'll be static, configuration, or the book calls it manual. right? We can statically set it for a trunk. We can statically set it for access port. Okay. There's a nice cute little table that's in chapter 8 that you guys need to go ahead and review. And this is what it looks like. It's actually a cross by cross table, right? And it tells us here, right? Let me go ahead and pull out my pencil, right? Hey, there's an access port, right? Whenever you configure the other side as an access port, what happens? It's access. If we configure one side to be an access port, right, but the other side to be a dynamic auto, what happens? It's still going to be an access port. Okay? Still going to be an access port. If we configure one side to be an access and one side to be a trunk, the book is telling you do not use, right? And there's a little star behind it. So let's read that. When two switches configure a mode of access on one hand and on another hand for it to be a trunk, problems occur. Avoid this combination. Okay? Right? But of course, if you configure one side to be access, one side, right, with dynamic trunking protocol, it's going to be access, right? Let's move on to, right, what happens if we set dynamic auto to one side and, dynamic auto to another side? It's going to be an access port. That's what we saw, right? It never came up as a trunk. It stayed as an access port. Keep that in your minds. But if we go to the next line, something different happens. One side for a dynamic auto, and one side we statically set as a trunk. It's going to come up as a trunk. Why? Right? Why does it come up as a trunk? Because we are setting the operational mode statically to say, I am a trunk. That is the messages. So that's why, right? That's why if you set one side to dynamic auto, one side to a trunk, it statically hears the messages, hey, I'm a trunk. It's going to set itself as a trunk. Okay? If we set one side to dynamic auto, which you guys just saw, one side to dynamic desirable, it's going to be a trunk. Okay? All right. Same goes for, of course, if we statically set one side as a trunk, even if we use dynamic auto, trunk, or dynamic desirable, it is going to become a trunk because communication from the other switch says, I am a trunk. There's no negotiation needed. I am a trunk. So it's going to set its side has a trunk. So that's the beauty of DTP, right? If it hears the other peer has a trunk, it's automatically going to set itself as a trunk, right? Okay. So last but not least, dynamic desirable. If it hears one side to be access port, it's going to be an access port. Other than that, it's going to set itself to be a trunk, right? So outside of the exam, if you guys are those engineers for the company, right? You're always going to set those ports, right? Those trunk links has dynamic desirable. You want them to initiate messages. You also want them to listen to messages. Okay. Um, in regards to network security, there's a different take on that, but we'll get to that in the future. Okay. With that being said, I know we're way past time, but I wanted to make this point. Um, I hopefully this added value today. We will come back on Thursday, and we would continue chapter 8. I thought we were going to be done. We're not going to be done yet. You guys know I'm long-winded, so we'll come back on Thursday and continue on with chapter 8. All right. You guys have a great one.
Thanks, David. Bye, y'all.